Hello 108 students, Mr. McHugh here with you. Hey, we are working our way through section 3.5 and we're going to cover page 4 here on this video. And we're going to keep taking this concept of identifying functions. And by the way, on my class notes, you see ID dot, it means identify, not Idaho for the state we live in. Okay, just a little, make sure you understand my notes there. How can you identify functions from looking at graphs and equations? Now, on the last page, in the last video, we had you go from the domain and range, and I dropped a little bit of a hint about doing the vertical line test. And so now we're officially introducing it. So this is a visual technique that if you have a graph, imagine taking a ruler out. And I'm going to try to illustrate this here. I'm going to use this tool and see if I can draw lines here. Here is the egg-shaped graph here, if you want to call it that. And what you do is pretend you're a scanner on your 4-in-1 printer, and you're going to do a scan. You know, when you do a scan, you start from left. Oh, look at that! Yeah, and you scanned. Now, as I start this from left to right, you can notice I have not touched the graph yet. Okay, so you're kind of getting the idea. Even if I come up to here, I have not touched the graph. All of a sudden, when I come in a little bit, I come here, and bingo, I look at it, and I go, how many times did I touch the graph? Let me come back here. And I touched it, look. 2 ordered pairs are represented, or even if you don't know what the exact numbers are, the ordered pair, they are stacked vertically. Therefore, this is not a function. Okay, and you're done. Once you fail it once, it's done. Now, this is a little bit of overkill, but I guess I like using this tool here. What if I came over here and did another scan, came down, and asked myself, how many places did I touch the graph? 2 places. If it's more than 1, it fails. Those ordered pairs, remember that x coordinate would stack right on top of each other, and it fails. Okay, so that's the idea, and I just want to encourage everybody here. I'm hoping you're using your textbook or your electronic book. On page 185 is where I'm at here, roughly, is example 4. I don't do every single example in the textbook in my class notes, but you need to engage, you need to read the textbook here. What I want to illustrate here, for example, is what happens if I had a graph and it was an S-shaped. Okay, this is in the book here, it goes like this, and I asked you to start to do the scanning. Is this a function, just looking at the graph? Now, when I started here, let's go to a different color, let's get a little crazy here. Let's use green. I don't know. And I ask you to do the vertical line test scanning. You come down. Oops, that's not a vertical line test. Sorry, that's a squiggly line test. Okay, so what happens if I come down here and I draw another line? I'm scanning, and you go, where did it touch? Only one place. And it looks like a function so far. And then all of a sudden, you come over and you draw one here, and boom. So I like saying it, I guess. How many places did you touch on that squiggly graph? Oh my word. 1, 2, 3, 4, 5 places. Is this a function? Absolutely not. You might not even have to do the whole vertical line test. You could see that visually. But that's the idea. Okay, so we'll go back to red mode here. Isn't this technology stuff amazing? Okay, so that's the idea. Vertical line test. Go from left to right. You must always only ever intersect the graph one place. That represents the ordered pairs not being stacked. Now, here we go. We've got a line, and we set it as a function, but if I do some scanning, and let's just go right here, pick a point. How many times did it touch? Right there. Do another one. And no matter how many times you scan going from left to right, you only ever going to touch the graph, the line, one spot. Okay. Oops, sorry, got to change my mode here. Okay, so this is just me telling you to go left to right as you scan. Okay, so that's the idea, and you can see a couple other examples on there. You can follow along. Okay, that was page 185. Another thing, I haven't mentioned this so far, but if I look on page 186 and 187, I'm going to give my kudos to this book and to the authors and their organizational skills. For you online students, you must engage in the textbook. I mean, I think that's one of your key resources. They do a great job. I'm going to call these blue highlights. There's boxes in here that they highlight things. Look at these boxes. Look at on page 186. It says agreement of domain. Read that stuff, okay? Don't just blow by it. Read it and understand what they're trying to tell you. Look at the variations of definitions of functions on page 187. There's 3 of them. Read those. Grapple with them. Hopefully between my class notes and the videos you'll do fine and you understand what they're telling you here, okay? So just take advantage of the book and its organizational skills. Anything you see highlighted in boxes, warnings, cautions, tables, please look at those, okay? Okay, now let's kind of wrap this up here. Example 5, it says identify functions from equations. Okay. Now, from a function, they go, is this a function? And ask yourself, y equals x plus 4. Okay, what type of function is this? What type of graph is this? I'm hoping everybody's telling me it's linear. It's in the form of what, class? Tell me. Y equals, say it, mx plus b. What's my name for this? Nickname. Golden function. A golden line. It's also a function. That y equals is a hint that it's a function. It's a line. For every value of x input, you get one and only one output of y. Okay, you could graph this. You know this is the slope would be what in this class? Ooh, I don't see nothing in front of the x. What's the default coefficient? You pop up the 1. Okay, so slope is 1. Up 1 over 1, right? Okay, what's the y-intercept? 4. Could you graph this? Let's do it. Okay. I'm simulate what I do impulse in class here. Up 1 unit, 2, 3, 4. 0, 4 is the y-intercept. Sorry, my graph's not all that great, but okay. From here, anchor point. Slope is up 1 over 1. Positive 1 over 1. Up 1 over 1. How about reverse slope? Negative 1 divided by negative 1 equals a positive 1. Down 1, back 1. Down 1, back 1. Okay, as you can see, it's like the steps going up and down in your house, and there you go. So this is, every linear equation is a function. Okay, now b has got a square root to it, and you go, ooh, I'm not quite sure how to figure this out. One way to do this here is to use an expanded XY table. Now this is a square root function, and we're going to cover a little more of these later on, but pick values for x, put them in, get a sense where you get a unique output. I picked these so that they were easy to do. 2 times 5 is what? 10. 10 minus 1 is 9. Square root of 9 is 3. Look at 13. 2 times 13 is what? 26 minus 1 is 25. The square root of 25 is 5. And so yes, this is a function. Okay, so that wraps up this section here. Now this was example 5. Look in the book here. Check some of the other ones in there. And make sure you're comfortable with all parts A through E there to help you with your homework. Okay, we have finished up page 4. Now I'm going to give everybody a heads up. We're going to go to page 5. It's when I wrote my class notes for the older version 10 of the book, they did not have section 3.6. They took my page 5 and 6 of my class notes was talking about functions, function notation. So page 5 and page 6 that you're going to see in your class notes cover what's in section 3.6 of our current version 11 book. Okay, so Mr. McHugh gonna say goodbye for now, and I will see you for our page 5 for section 3.5/6. Okay, bye.